Good day to our lecturer, Dr. Adam Wong, and everyone. Today we'll be discussing our assignment titled Digital Signal Processing Windowing Filter. Our group consists of two people only, that is Muhammad Syamil IZZUDDIN, metric number B122310525. Next, LuqMaan bin ZulKifli, number metric B122310015. We will explore how windowing filter play a critical role in signal processing, particularly in FIR filter design. Next, let's start with basics. Introduction to window filter. Windowing filter are vital in filter design because they help shape the frequency response. Their purpose is to apply a window function to the ideal impulse response and truncate the infinite impulse response to a particular finite line. After that, we go to the type of windowing filter. Windowing filter comes in several forms, such as rectangular, Hamming, Han-Blackman, Harris, Kaiser, Ballard, Cauchy, Welch, flat top, and Nuttall window. Each type has a unique characteristic that makes it suited for a specific task in signal processing. In this presentation, we will focus on Hamming and Kaiser window only. Now let's dive to the key characteristic of window filter. Window filter have four important characteristics that affect how they work. First, side loop separation help reduce unwanted noise outside the main frequency, improving signal clarity. Next is the main loop width, which determines how sharp or focused the main frequency peak is. A narrower main loop gives better precision. Third, we have frequency resolution, which measures the filter ability to separate two closely spaced frequencies. Better resolution means more accurate filtering. Finally, there's the ringing effect, which refers to unwanted ripple caused by suddenly cutting off signal. This can distort the output if not controlled properly. This characteristic guide us in choosing the right windowing filter for different applications. After that, we go to the application of windowing filter. Windowing filters are used in many important applications. They help in designing FR filters such as low pass, high pass, band pass, and band stop filter to shape the frequency response. They are also used in spectral analysis for speech and audio processing, breaking down signal into their frequency component. This is essential for understanding sound pattern and detecting anomalies. Another use is reducing leakage in Fourier transforms, which ensure more accurate frequency analysis by minimizing unwanted signal spreading. These applications show how windowing filter improve precision and performance in signal processing tasks. Next, we go to the choice of windowing filter. In this assignment, we focus on two popular windowing filters, the Hamming window and the Kaiser window. Each has unique strengths and is chosen based on the specific needs of the application. Next, our objective for the assignment first to explain the characteristic and difference between the two filters. Number two is to demonstrate how to design filter using each window. Lastly, to showcase one practical application for each filter. By comparing the filter, we aim to understand the strength and decide which is better suited for different scenario in signal processing. Next, to designing window filter. To compare the performance of the Hamming and Kaiser window, we design filter using the same specifications. These include the filter types using FIR high pass filter, cut-off frequency at 100 Hz, and filter order at 101, which are shown in the figure 1. Through this design process, we aim to highlight how the choice of a window impacts the frequency response and overall performance of the filter. By following the specification before, we implementing Hamming and Kaiser windowing filter in MATLAB. To analyze the Hamming and Kaiser window, we use MATLAB to design and implement the filter. The code begins by defining the filter specification, such as the cut-off frequency, filter order, and the type of window. For the Hamming window, we use the Hamming function in MATLAB to generate the window coefficient, which will then apply to the filter design. For the Kaiser window, we use the Kaiser function, which include an adjustable parameter, beta, allowing us to customize the side loop separation and main loop width. This makes the Kaiser window more flexible but also slightly more complex to implement. The result from the MATLAB could provide us with an impulse response and frequency response for both filters. These outputs are key to comparing their performance and understanding how each window affects the signal processing. Here we have the impulse response graph for the Hamming and Kaiser window. The Hamming window shows a small curve designed to reduce spectral leakage by tapering the signal. It's simple and effective for general tasks like audio and speech processing, while the Kaiser window is more flexible with adjustable sharpness and side lobe separation controlled by the beta parameter. This makes it ideal for applications requiring precision like radar or communication. Next, we go for this slide. We show the frequency response graph for the Hamming and Kaiser window. The Hamming window has a wider main lobe and moderate side lobe separation. This makes it suitable for general tasks but with less precise frequency resolution. Next, for the Kaiser window, show a narrower main loop and much better side loop separation. Thanks to the adjustable beta parameter, this gives it higher precision and is ideal for applications requiring sharper filter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syamil IZZUDDIN bin Abdul Rahim. For my metric number is B122310525. On my session, I want to explain about the filter we choose, which is hammering windowing filter and Kaiser windowing filter. Furthermore, I will conclude the description, characteristic and application for each filter. Lastly, I will compare between the filter we chose and give a conclusion on hammering windowing filter and Kaiser windowing filter and our filter design. Okay, firstly, for hammering windowing filter is a type of windowing function commonly used in a signal processing to smooth a signal before applying a Fourier transform. It helps reduce spectral leakage, which occur when finite length signals are transformed into the frequency domain. For the hammering windowing filter, it has four main characteristics, which is number 1, side lobe separation, 2, moderate attenuation of side lobes around -41 dB. Number 2, main lobe width, which is slightly wider main lobe compared to a rectangular window. Number 3, frequency resolution, to moderate frequency resolution due to the wider main lobe. Number 4, ringing effect, low ringing effect because the edges are tempered smoothly. Okay, next. For hammering windowing filter application, it has 5 main application, which is number 1, frequency analysis. It helps smooth this edge, making the analysis more accurate. Number 2, filter design. It used to make the filter response smoother. Number 3, speech and audio processing, which is help smooth the signal to avoid harsh transition, leading to clearer audio analysis. Number 4, image processing. It helps makes filter smoother, which is reduce noise and unwanted effect when processing images. Number 5, radar and communication. It helps improve signal quality by reducing interference and making sure the signal is clean when analyzing its frequency content. Next, I will explain about Kaiser windowing filter. Kaiser windowing filter is a flexible windowing function used in signal processing, known for its adjustable shape. It is defined using a parameter B, which is beta, which control the trade-off between the width of the main lobe and attenuation of the side lobe. The Kaiser windowing filter is derived from the zero-order modified Bessel function of the first kind. For the Kaiser windowing filter, it has 4 main characteristics, which is side lobe separation, to adjustable based on the parameter B, beta. Number 2, main lobe width, increasing beta within the main loop. Number 3, frequency resolution, a higher beta reduced resolution due to the wider main lobe. Number 4, ringing effect, minimal ringing effect for moderate to moderate to hide beta. Next, for Kaiser windowing filter application, it has 5 main application, which is number 1, filter design. It helps create filter that can block or pass certain frequency. Number 2, spectral analysis. It helps analyze signals by reducing noise when transforming a signal into frequency component. Number 3, audio and speed processing. It helps clean up signal by filtering out unwanted noise and improving clarity. Number 4, radar and communication. It improves radar and communication signal by reducing interference, allowing a clearer signal analysis. Number 5, image processing. It helps prevent distortion and error when changing the sampling rate. Alright. Next, we go to the comparison between Hamming windowing filter and Kaiser windowing filter. Okay, I want to explain the Hamming and Kaiser, which is Hamming reduce unwanted noise when analyzing signal, while Kaiser give more control when designing filter, especially in more complex tasks, like communication or radar. Second, Hamming filter simple to use and work well for many tasks, while Kaiser filter can adjust the beta parameter to control how sharp or smooth the filter is. Number 3, the Hamming filter is fixed shape, while the Kaiser are more flexibility. Number 4, the Hamming windowing filter are simple tasks, while the Kaiser windowing filter are more complex filtering, where precision and customization are needed. Lastly, the conclusion is the Hamming window is best for simple tasks where the ease of use and speed are important, making it ideal for general application like audio and speeches processing, where the moderate performance and reduced spectral leakage are sufficient. It is easy to apply but lack flexibility in control filter characteristic. On the other hand, the Kaiser window offers greater flexibility, allowing precise control over the filter sharpness and side lobe suppression of the adjustable B parameter, making it better suited for complex tasks. However, it's more complex. In short, the Hamming window is suitable for straightforward application, while the Kaiser window is ideal for secondary areas requiring customization, high performance filtering. That's all for me. Thank you very much.